we're going to be talking about how to use GeoGebra to make dynamic proofs. And what I'm going to be doing initially is just helping you with the setup. So this is something I've already created. It's Young's geometry, where you have clickable lines, and so you can highlight different lines or points in the geometry. So we're going to create a little bit of that. So the first thing I'm going to do is I'm going to create all the points. So I'm going to use the grid. I'm going to start with A equals 0, 2. And then B, I'm going to go right across. So this will be 1, 2. And then C equals 2, 2. And D equals, now we're to 0, 1. And I'll pause this and finish. All right, so I have my 9 points, and I've gone across the top row is A, B, C, and then D, E, F, and that's important. I've labeled them in order so I can figure out what their labels are later, even if I don't see their labels. This drawing's going to get busy. So now what I need is my lines. So I'm going to use the segment command, and I'm going to use AC is going to be my first one, and then DF, and then GI. And I'm also going to do the vertical ones. Wait, I've messed up here, but that's fine. What I want to do is I want to name them something. So rather than let the computer take over, I want to name them. So here I'm going to use L, and I'm hitting the, I'm using lowercase l and the underscore. I don't know if you can see that, but that's created a subscript L1 equals, and then I can call that segment AC, okay? So now I have L1 and then L underscore 2, and I'm hitting the right arrow. Do you see the cursor's down in the subscript location, where if I were to type, I'd have more subscript, but when I hit the right arrow, it hops back up, and I can do equals segment DF, L3 equals segment GI. Okay, and you see what I'm doing. I'm going to finish this. I'm going to pause the video, and I'm going to make the vertical lines these horizontal lines, and I'll show back up when I'm trying to do the lines that curve around like that. So like I said, the picture is getting a little bit busy, but you see the stuff I have here, and you can always turn stuff off. If it's getting in the way, you can take it out just by clicking on the dots, and it'll disappear. So now I need a couple of other segments, and I'm going to name them something different. The reason being, because I want to be able to call them later and know what they're named. And so what I'm going to do is I'm going to create this line here. Sorry, it goes down here. Right, I'm going to create this one. It's going to be a line segment here that I'm going to call P1. And it's going to be this arc. I'm going to make a circular arc. That's not a circle, but we will have a circle soon. A circular arc around here that is Q1. So I'll have P1 and Q1, and I know that they make this first kind of circular line that we need. So the first thing I'm going to do is P with a subscript 1 equals segment DB. Okay. And then I want to make this circular arc, and to do it, I'm going to need another point out here. So I am going to create just a random point, R equals, and this is going to be 3, 2, I think. Yep, that's where I wanted it. So now I can make a circle through C, 3 points. I don't need really to name the circle anything. I just need the 3 points. I'm going to make it through B and R and I. Okay, so this is cool. What I'm going to do is I'm going to create a circular arc from B to R to I. Hopefully, we'll see how this goes. All right, so arc, wait, I want to name this Q1, right? So P1, Q1 is going to be this whole line. So Q underscore 1 equals arc. And so I tell it the circle's name is C, and then I tell it 2 points on the circle. And I think the right order is B and then I. Nope, that went the wrong way. So I and then B. Again, you can kind of see a little better live whether or not you're getting the correct arc, but the easiest way to tell is just to hide the circle and see which part of this stays. But I do have the correct part, and notice that my P1, I'll turn it on and off so you can see it blinking there. My P1 and my Q1 look like they could be the same line. All right. Um, so I'm going to do Q2, Q3, Q4, and P2, 3, and 4, and I'll be back. So we're back with everything drawn, and you can see that it's really busy, and it's busy even though I've turned the circles off. So I have what I need. I have it named properly. I'm going to do a couple of things to make it easier to work with. First of all, I'm going to turn off all the labels, and I was going to show you there's a way. It's a little tricky sometimes, but if I can get the whole thing highlighted and I am left clicking on one of these things here, and then I can go to show label. And if I get it all selected at once, it'll turn all the labels off at once. So that was right click to drag and select the figure, and then left click on the figure, and then be able to click on show labels. That turns them all back on, that turns them off. So that's a little pro tip for you. Now, a couple of things. I'm going to turn off these ancillary points, RSTU, because I don't want them. They're not actually in the geometry, so I want to hide them. You can make this a little bigger if you'd like, just to make it a little easier to work with. And so next, I want to make my lines and points bigger. So what I'm going to do is I'm going to use green like I did in the notes, and 10 is usually a good size for these lines. I can just come through green and then size 10. So I'll pause this while I... Okay, so now I want to take care of these points. So the points should be green and big. You can go either 8 or 9. The drawing's really busy. Normally I use 8, but this drawing's so busy, I think I'm going to really accentuate the points. I also want them green. That's what I've done in the other drawings and the ones I used in our course notes, so I'll stick with that. Pausing again till I finish. All right, and now I'm just about done, but now I'm gonna highlight some of these circles as orange and some of them as red. So let me start here. So I'll make this one orange and make it 10 point. And then here's a trick I've showed in another video. I want to click on the plus, and I want to get this in my recent so I can grab it for these. The arcs use a slightly different, they have slightly different default settings. So when I come in here and I click on the color, I don't have the one I'm looking for. But if I can go plus, click on the recent, then I get exactly what I need. And then I can make that 10 point as well. And then I want to do this one is orange and 10 point. And this one will be recent orange 10 point. Okay, and I'll do the red ones and be right back with you. Okay, so now I have my whole drawing. And what I want to do is I want to create different checkboxes to show different pieces of a theorem that I'm working on. So what I'm going to use, the toolbox I'm going to use is over here under the construct tools. And if you scroll down, I have to click more. And it's almost all the way to the bottom. And we're going to use a checkbox. Okay, so you click on checkbox, you click out here somewhere, and you get to give it a name. And so I'm going to show you how this works with a very simple theorem that I'm creating. So I've hidden everything. They're still there, but I've hidden everything for the moment. Because now I'm going to put in some text boxes and things. So the first thing I'm going to do is jump over in here, and I want a text box just here. And I'm going to give this thing a title. So it's going to be theorem in Young's geometry. There exists at least 4 points. So I'm not going to spend a ton of time um, showing you how, but you can set a color and the main thing is, sorry, let me click back on that and to settings. When you get to text, it's on small. Large goes a long way. Huge, it covers like most of the area we've got here. I'm right clicking to kind of get that centered. And yes, if you want to, you can come in here now. We don't really need the grid anymore. It's just kind of busy. Okay, so, oops, and now it wants another text box. So before I do that, let me just say we are proving that there are at least 4 points. And so what I need is to show the following steps. We're first going to say by axiom 1, there's a line. And so you see this line here. And over here you can see it's line L1. Okay? So what I want to do is I want to create a checkbox that says there exists at least one line by axiom 1. And I want it connected. I want both the text and the line connected. So let me create the text box first. So I've got to go back here, text, and I'm going to use actually I won't use a LaTeX formula right this second. So there exists a line, and that's YG axiom 1. Okay, so I don't know. I'd probably pretty this up a little bit. I'm just trying to get something up here for you guys. So this is the text that I want to show up, and this is the line that I want to show up. And I want them both to show up when I click a checkbox. So I'm coming down to this checkbox, which is here. I'm going to put it right next to this one, right? And caption, I'll just call it 1 or step 1. And then this gives you a drop down to select what you want. This is why I named them very particular things. So what I want to show up is actually called L1. It's the segment that goes through AC. And I also want the new text box, which should be all the way at the bottom. Sorry that that's going off the screen. Text 1 right there is the title, and I'm dropping right below that into a part of the screen you can't see to get text 2, which I hope is the right thing. And now when I click on this, oops, sorry, let me get to this move tool. All right, it was ready to create another box. Now it's going to show those two things simultaneously when I click on the box, right? So I can move this. Also, I can pretty this up in just a minute. Let me do something like that. Step 1, there exists a line. And then the next thing is that I need a text box that says there are exactly 3 points on each line. Has exactly 3 points, and I believe that's Young's geometry axiom 2. And this is my second step. Okay, so I want another checkbox that says step 2, but what I want it to do is I want it to show these points A, B, and C that are on this line, right? So I'm gonna make those visible so I can click on them. So jumping back in to the checkbox, pointing in between those lines of text there, we'll call this step 2. And so what am I going for? I'm going for point A and point B and point C. And I think that's all that I need. Oh, and I need this text box that I just created, which again is going to be all the way at the bottom. And it's right below that text too. So I'm dropping down and clicking on it. And now click OK. And when I get back to regular move mode, you can see that I can click on this and my points show up. You can right click and drag to get these kind of over here out of the way. So step 2, let me click on this. And yes, it's getting in the middle of my drawing. I see that, but we can work on that in just a minute. And so then axiom 3 says that that not all points are on the same line. So we know there's another point somewhere. So wait, I need a text box. And so not all points are on same line. And by the way, you can put some line breaks, some hard returns in here if you need to. So I've got YG axiom 3. I may have axiom 2 and 3 switched, but again, this is more training on how to do it rather than trying to get the proof exactly right this second. So checkbox, boom, now I'm gonna have step 3. And what do I want to show now? I want to show any other point, but this one is actually the one I'm going to grab is called G. And I also want to grab so I want to grab this text box 4. Why isn't point G showing up? Okay. We'll see what's going on here. I guess that was because it was hidden. I don't know. Let's unhide it. So G, and see if this works. Nope. So here's what you do. This happens a lot. This happens a lot. So what I want to do is I want to find out what step 3 is. Let me just show you real quickly what's going on, like with this point, for example. If I click on its settings and I go into the advanced, it tells me that whenever B is true, that's the condition on which it's going to show. So when B is false, then it won't show. Well, that means that one of these checkboxes is called B. Okay. So what do? Well, I come down here and I start looking at my check boxes, and you can see the check boxes have these big check marks in them. And here's the one that's called B. So I know that this is the one that's controlling this. And if I wanted something else to come on and off in step 2, then I would just set B to be its condition. Well, I do want something else to come on for step 3. I want this point G to do it. So I'm going to come back up here to my point G, and I'm going to go into my settings, right? So you can see that it's point G here. Come over to advanced, and the condition on which I want it to show object is C, and I'm hitting enter just to make sure that that's connected. If you just type it in and leave it and don't hit enter or tab or something to enter that letter in there, it goes away. So let's see now. Well, I don't seem to have managed it. Let me take a look at G. So I can click on this and go to settings. Just want C. I'm not quite sure. Oh, it's G. Now that's what I was missing. I figured since this one was A, I didn't even look. I saw A, B, so I figured obviously the next thing is C. I forgot that it made the circles, lowercase c, C, D, E, and F. So it's now lowercase g is what I need up here rather than C. So, oops. Enter. Okay. Now, okay, so they're coming in. All right, and not all points are on the same line. What happened there? Just delete one of them. Now I've got a bunch of them. Okay, so I can click on this one. And which one's coming in? Make sure that I know which one's coming in. And this is the one that can get deleted. So while I was clicking around there, I managed to get some extra copies made. And I'm right clicking to move these things. And so now you can see that my proof is going to start like this. So here's the presentation of the proof. All right, so the theorem I'm supposed to prove is that there are at least 4 points in Young's geometry. So by axiom 1, there's a line. By axiom 2, each line has exactly 3 points, so let those 3 points be there. And then step 3, since not all points are on the same line, there is some other line, some other point in the geometry, okay? Now we have 4 points, so QED, we're done. So in recap, this is just these are just different techniques that you're going to need to create these dynamic proofs where you can make a presentation just like that. using the checkboxes to show the steps as you go.